Hello everybody, welcome to 1.7 solving problems involving objects. This lesson will focus on solving problems that involve the surface area and volumes of a composite object. So essentially what a composite object is, it's an object that comprises of two or more distinct objects. So as you can see in your diagram, we have a cylinder here and there's a cone shaped on top. So there's two three-dimensional objects to create this composite object. So the farmer's constructing a new grain bin. The bin she would like to build a cylindrical body, that's right here, and a cone shaped roof, like I mentioned. All right. So here's the dimensions, just an idea of what it looks like. So we got 20 coming across from here to here. So 20 would be the diameter of the cylinder and the cone. 19 feet, that would be the height of the cylinder, and 5 feet coming from the center of the top of the cylinder or the base of the cone, going right to the top here is 5 feet. All right. So to determine the volume of composite object, identify the distinct object, calculate the volume of each, and then add the two together. Pretty straightforward. Okay. Let's look at example 1. So you can look at this object, and I think you can clearly, it's clearly easy to notice that we have two. This object comes with two objects here. First one, the bottom, if you wish, is a right rectangular prism, and we're going to have to add a right rectangular pyramid to it. All right, I think that's pretty straightforward. Pretty easy to identify there. Okay, so first we'll do the prism. So the volume, and I'll just name it. Oh, sorry, I'll just name it volume of the prism. Okay, you can put short for whatever you like. Volume of the prism. And that's simply equal to length times width times height, right? As you guys are aware. Okay, so we'll calculate that. And that's going to be equal to 6.7. Make sure all the units are the same. They're all in meters, so we can just multiply the length times the width, 2.9, times the height, which is also 2.9. Okay, and you're going to multiply that on your calculator, and you get, just make sure you punch it in. And you get 6.7 multiplied by 2.9 multiplied by 2.9, and you get 56.347. That is that number is a terminating decimal, so we'll just leave it for now. Okay, and now we're going to calculate the volume of a pyramid. All right, so now we'll do the volume of the pyramid. Oh. There we go, that's better. And we know that it's very similar. It's just going to be 1/3 of that, right? That's what we learned the other day. So you just go to your formula sheet if you don't remember that. You don't have to memorize it, it'll be given. So it's 1/3 of the length times the width times the height. So the length and the width are going to be equivalent to that of the rectangular prism because it sits right on top, as you can see here. So 6.7 would also have a 6.7 here, and 2.9 would have a 2.9 here. All right, so let's calculate that. We get, I'm going to steal that 1/3. All right, and we know that the length is also 6.7 because they share that side, and the width is also 2.9, but the height is different. The height of the pyramid is 2.1, where the height of the prism was 2.9. Calculate those. So we'll go 6.7 multiplied by 2.9 multiplied by 2.1. We'll take 1/3 of that, which is the same as dividing by 3. We get 13.601. All right. So then we say that the volume sorry, this is just me being lazy. The volume total is equal to the volume of the prism plus the volume of the pyramid, right? So we just have to add the two of them together, and we get equals 56.347 plus 13.601, which is equal to 69.948. And we'll put the units in, and it says to the nearest tenth of a cubic meter. So that means that the 4 leaves a 9 as a 9. So that's going to equal 69.9. And we had the units at meters. So it's meters cubed, right? Because its volume is always going to be cubed. So it's going to be meters cubed. And then we can write a little sentence. Steal that to be lazy again. The volume of the composite object is approximately, and I'll steal that around it. Okay, and that's it. There's a check your understanding example that's going to go along with this. This one here is a little different. They're using the some similar to the diagram we saw on the first page. We have a cylinder and a hemisphere. Remember that. Okay? It's not a whole sphere, it's a hemisphere. And then your answer is going to be approximately 44,786.5 centimeters cubed. All right? Next, we're going to look at how to determine the surface area of a composite object. So we'll do this in example 2. So determine the surface area. So we know that we have the surface area of a hemisphere, right? Okay. And the surface area of a cylinder, but there's going to be parts that aren't included. So in surface area, you got to get rid of some values, okay? So we got to be careful of that. So if you look at this object and you want to try to calculate the surface area, all right? When we calculate the surface area is going to equal 2 pi r squared. Okay, so that is half of the sphere, so the hemisphere. All right, we don't need the base, which was pi r squared, because we already have that. And then we need to get the base here, so that's going to be pi r squared again. All right, pi r squared again, because we know the area of a circle is pi r squared. And then we need the part of the cylinder that wraps around here. That flattens out to be a rectangle, and that's going to be given by, if you do recall, that's given to you by 2 pi r(h). So 2 pi r multiplied by height. And there's the surface area of this object, okay, of this composite object. And you notice that these are like terms, so we can add them together if you want to simplify. Because if you have 2 pi r squareds and 1 pi r squared, that means we have 3 pi r squareds. Okay? The 2 pi r squared is coming from the surface area of the hemisphere when it was cut in half, minus the base, of course. The pi r squared is coming from the circle, and the 2 pi r squared is coming from the area of the curved part of the cylinder that goes around. Okay? And there's your formula. So now we're just going to substitute our values in. So we got our radius, which is 2. Got a radius, which is 2, and our height, which is 4. Okay? There we are. So now we'll multiply and then add these together. So we got 2 squared is 4 times 3 is 12 pi. So 2 squared is 4 multiplied by 3 is 12 pi, and then 2 times 2 is 4. And we have 16 pi here. 2 times 2 is 4 times 4 is 16, so we have 16 pi. We add the two of those together. Add the two of those together, and we get 28 pi. Right? 16 plus 12 is 28, and they both had pi, so they're considered like terms. And now we can just plug it in our calculator, right? So this, the only point Tiny had to get to your calculator is this last step. So literally don't put 28 multiplied by 3.14, put 28 times pi or 28 pi on your calculator. We get 87 decimal 9645943. That goes on forever. Okay. So it says determine the surface area of this composite object to the nearest square foot. So that means the 9 is going to round the 7 up to an 88. So we're going to have surface area is equal to 88, and we know the units are square foot. So grab an exponent. And we have okay. And we say the surface area of the composite object. The surface area of this composite object is approximately 88 feet squared. That's it. And we're finished. All right. And then there's a check your understanding question that goes with this as well. And you're just doing the surface area of this. Looks like a cube and a square base pyramid. You're going to get an answer of 165. Remember, eliminate what you don't need from the formulas. All right. That's it for me for this video. In the next video, we'll look at example 3, solving a problem related to a composite object. All right. Well, thanks for everybody, and we'll see you again in the next video. Thank you.